Okay, looking at polar graphs, we're going to look at circles and roses in this. There are two types of circles that we're going to do in polar world. The first one is what we did in class the other day. If you know that r equals a number, r is your distance from the origin. So if r is equal to 3, that means I need to go out 3 units in all directions. So 3 units, 1, 2, 3, 3 units, 1, 2, 3. We'll count off 3 in all 4 directions, and then we'll draw a circle that has that radius. So this probably isn't going to be a pretty circle. It's not too bad. It's kind of ellipsoid, whatever. So that would be a circle with radius 3. Goes through 3 on both x and y axes and negative 3. Here we have r equals negative 4. Even though r is negative 4, that is still a radius of 4. Now I'm going to be really lazy here. I'm just going to say, hey, there's 4, and then we'll go up to 4 here. Then we'll go to negative 4 out here. Then we'll go to negative 4 down here. And again, I'll draw a circle that hits those 4 points. That's pretty good. And there's my circle. The other type of circle, and this one's a little bit more confusing, is in the form r equals a number times either sine or cosine. It goes through the origin, and then it goes 3 units out in one of the 4 directions. And what I mean by that, like number 3 or number a here, number a, it's 3 times sine theta. The way I remember where this circle goes, I'm actually going to do something weird. I'm actually going to graph it first and then explain the graph. It's going to go out on the y-axis. That's a horrible circle. I'll just drag it over. This is what that circle's, hey, I'm trying to move you there. That's what this circle is going to look like. It starts at the origin, then it goes out 3 units up the y-axis. 1, 2, that was really bad. Let's scale that better. 1, 2, 3. Goes 3 units up. This one, it's negative 4 cosine theta. That one's actually going to go 4 units to the left. Negative 4 units that way. And so this circle is going to end up being something like, I'm going to make this a little better. Let's drag that into position. There, that circle is going to look like this. The way I remember where these circles go, when I'm graphing these, first I identify that it is a circle formula. It's in that general form, a number times sine or cosine. If you think about the unit circle, sine is associated with the y-coordinate, cosine is associated with the x-coordinate. So when I see 3 sine, I'm thinking 3 times the y, which means I'm going to go up to 3 on my y-axis. Cosine is associated with the x, as it's your x-coordinate on the unit circle. So cosine, if it's negative 4 cosine, that's negative 4x, I'm going to go to negative 4 on the x-axis. So using that thinking, if I see negative 2 sine, well, sine corresponds to y-coordinates, and negative 2 means I'm going to go down 2 units on the y-axis, and that's what this circle is going to look like. So let's see if I can get this one to look halfway decent. Jeez, I suck at this. All right. There we go. So that'll be one going down to negative 2. So just keep in mind that when you're graphing these, cosine is associated with the x's, sine is associated with the y-axis. There we go. Just like it was on the unit circle. So there's our 2 types of circles. Those are kind of nice, where you have r equals a number and r equals a number times sine or cosine theta, and you just have those circles, not a whole lot to it. The other type of graph I want to look at is called a rose graph, and these are much more difficult than the circles. Still very formula driven though. You need to recognize a circle, a rose when you see one. It's a number times either sine or cosine, and then n theta. Let's look at the cosine ones first because they're a little bit easier, not a whole lot, but the number a tells you how long each petal is. This number right here, n, tells you how many petals there are, and the tricky part is that there are 2 rules. If n is an odd number, then that's how many petals there are. If n is even, then you double that number. If And then if you have a cosine, your first pedal is always on the x-axis. And I should specify the positive x-axis. You don't start on the negative x-axis. Uh, the positive x-axis and the pedals are evenly spaced. So with those notes, let's do one with real numbers so it'll make a little bit more sense. Let's look at 3 cosine 2 theta. Now when I'm looking at this one, the first thing I do is I notice that I have this 3. That means each pedal is 3 units long. Each pedal is 3 units long. Okay, this number right here tells you how many pedals there are, but since that is an even number, if that's an even number, you double it. So there's going to be 4 pedals. And then since this is cosine, I know my first pedal is going to go out towards the x-axis. 1, 2, 3, 4 units. We know it's 4 units long, or 3 units long. And I'm going to have 4 pedals. My first pedal comes out looking like this. It goes through the origin, then it comes up, and there's my first pedal. If there are 4 pedals total, they are going to be spaced out evenly. There's 360 degrees in the whole circle going all the way around. If you divide that by 4, then each pedal is going to be 90 degrees apart. Now this is going to be really easy because if the first one starts on the x-axis and they're evenly spaced out, then the rest of them are just going to go out on each axis. So I'm going to go up 3, I'm going to go left 3, and I'm going to go down 3. And these pedals, I'm going to have a pedal going up like this. That's kind of ugly. I'm going to have another pedal coming out like this. That one's a little bit prettier. Another pedal coming down like this. They're all 3 units long. They should be the same size and shape and everything. That's really hard to do. But that is what this rose graph is going to look like. That's called a rose. You have 4 pedals. Each pedal is 3 units long. Let's look at this one. This one, number 2, I'm going to have 3 pedals. It's an odd number this time. So since that's 3 times theta, it's going to be 3 pedals. And each pedal is going to be 5 units long. And here, if I have 3 pedals, if they're evenly spaced out, I have 360 degrees. If I divide that by 3, each pedal is going to be 120 degrees apart. And since this is a cosine graph, my first pedal is going to go out 5 units on the x-axis. So here's my first pedal. I'll do it in blue. So here comes my first pedal. Like that. And then the next pedal is going to be 120 degrees further. So the way I find that next pedal, my first pedal started out at 0. I need to go all the way to 120. That's 90. And 120 is another 30 degrees this way. So I would go 120 degrees further. So this is at 120 degrees. And that's where my next pedal is going to be. So I'm going to go out 1, 2, 3, 4, 5 towards 120 degrees. There we go. My next pedal, I'm going to go 120 degrees further. So if I'm at 120, my next pedal is going to be 120 degrees more, which would put me at 240. Now on the unit circle, 240 is about down here. So I would go down 120 degrees more. That's 240 degrees. And I'll draw my third pedal, and this is my final one. 1, 2, 3, 4, 5. And there's my last pedal. And then if I did go 120 degrees more, it will take me back to the beginning. So there's the graph of 5 cosine 3 theta. Good, good? Let's see. So we have 3 cosine 2 theta, 5 cosine 3 theta, both rose graphs. There's one more cosine one I wanted to do. This one, how many pedals on this one? Let's see, 4 times theta, but 4 is even, so we're going to double that. We're going to have 8 pedals. And if you have 8 pedals, 360 divided by 8 is going to be 45 degrees. So we're going to have 8 pedals, 45 degrees apart, and they're each going to be 2 units long. So for this one, that's a lot of pedals. My first pedal, I'm going to go out 1, 2 units. And my first pedal is going to look like this. Now I have a whole lot of pedals on this one, so I'm going to try to keep my pedals skinny to make sure I have room. My next one, I'm going to go 45 degrees out. So my next pedal goes out 45. Okay. Anyway, let's see. So 45 degrees would be there's 0, 45 degrees splits perfectly. My next one would be 45 degrees further, which will be at 90 degrees. If I went 45 degrees further, I would go out here towards 135. And each pedal is going to be separated by 45 degrees, and this is where all 8 of my pedals are going to be pointed. Each one is going to be 2 units long. So let's see. 1, 2 units, 1, 2 units, 1, 2 units, 1, 2 units, 1, 2, 1, 2, 1, 2, and then we'll just draw all the rest. And I'm going to go kind of weird here when I'm drawing these. Let's go down and get this one. And I'm just going to make it like one big continuous, like I'm drawing a bunch of crazy infinity looking things. So let's see, go up, hit that one. Let's go get this one down here. Ooh, they overlapped. That was bad. That little spot right here where they overlapped shouldn't happen, but this is what happens when I try to cram too many pedals in. See there, those overlapped again. Wow, this is ugly. But there we go. There's an 8-pedaled rose. Don't judge me. Okay, talk about sine for a minute. The A and the N mean the same thing. That's the same as a cosine one. A tells you how long the pedals are. N, if it's even, you have 2 N pedals. If it's odd, that's how many pedals there are. But with a sine graph, your first pedal is not sitting on the x-axis. The sine graph is actually a lot more difficult. The first pedal, you start by finding its angle of elevation by doing 90 degrees divided by N, or if you're determined to use radians, it's pi over 2N. And I put first in quotations because there's really not a first pedal. There's more, maybe, yeah, you just kind of have pedals, but we're going to start with that pedal that's in at that angle. Boy, I just really fumbled through that sentence. We'll pretend that never happened. Let's try one here. Let's identify the number of pedals and how long they are. This one, you have 3 theta, so there's 3 pedals. That's an odd number, so that's how many pedals you have. And if there are 3 pedals, 360 degrees divided by 3, each pedal is going to be 120 degrees apart. And each pedal is also going to be 4 units long. Now the difference between sine and cosine is you do not start the sine pedals on the x-axis. My first pedal is going to be raised by an angle of 90 divided by 3 degrees. So my first pedal is at an angle of 90 degrees divided by 3, which is 30 degrees. So I'm going to start with my first pedal not on the x-axis, but up 30 degrees. So if here's 30 degrees, my first pedal is going to go 4 units out in that direction. So 1, 2, 3, 4, and I'm going to go out in that direction of 30 degrees. Then I have to remember that my pedals are 120 degrees apart. So if my first pedal is at 30 degrees, my next one, 30 plus 120, puts me all the way at 150 degrees. So my next pedal is going to be over here at 150 degrees, and if you remember your unit circle, you remember where 150 is. And there is where my second pedal is going to go. Oh, it's 4 units, not 3 units. So 4 units, there's my second pedal. And this angle right here, that angle is 120 degrees. All pedals are 120 degrees apart. So I went towards 150, and then 150 plus 120 would take me down to 270, and 270 is the negative, oh geez, your negative y-axis. So there's 270. And that's where my final and third pedal is going to be. So 1, 2, 3, 4 units long. And there is my third pedal for that graph. Let's try this one. R is sine 2 theta. Now the number in front of theta is even, and if that number is even, that means you double it, so we actually have 4 pedals. And 4 pedals means that, let's see, 4 petals means that each petal is going to be 360 divided by 4, which is 90 degrees apart. And each petal is also going to be 1 unit long. There's an understood 1 in front there, so each petal is just 1 unit long. Kind of short petals. My first petal is going to be at 90 degrees divided by whatever the coefficient of theta is, 2. So my first petal is going to be going off at 40 degrees. That was terrible. 45 degrees maybe? So let me get my first petal going 45 degrees. And I'm going to go ahead and plan out all 4 of my petals. If I start at 45 degrees and my next petal is 90 degrees further around, then my next petal is going to end up going, let's see, I'm at 45. My next petal is going to be 45 plus 90, which is 135. And we're going to end up splitting each quadrant perfectly at the 45 degree angles. Each petal is going to be 1 unit long. So I'll put 1, 1, 1, 1. And this graph is going to look something like this. Go out 1 unit, and there is the graph of sine 2 theta. All right, 2 more. 5 sine 4 theta. Ah, geez, I did it again. Too many petals. All right, it's an even number, 4 theta. That means 8 petals. And 8 petals means they're going to be 45 degrees apart. You do 360 divided by 8. Let's see, they are 5 units long. Oh, this is going to be rough. I see something tough in the future. 5 units long. And then we need to find out where that first petal is going. So my first petal is going to be heading off at the angle of 90 divided by 4, which is 22.5 degrees, which is kind of mean. Not kind of mean, that is mean. So 22.5 degrees is going to be about up here. But then I need to add 45 degrees to that to get to my next angle. So there's 22.5. My petals are 45 degrees apart. 22.5 plus 45 is what? 67.5. That's going to be somewhere up here. And what's going to happen with these petals is we are now going to put 2 petals in each quadrant. We're going to have one about right here. We're going to have another one about out here. We're going to have one over here. We're going to have one down here. We're going to have one down here. And then we'll have our 8th one right here. They are 5 units long. Now I'm going to be lazy and I'm going to say, hey, there is 5 units. There's 5 units. There's 5 units. And I'm okay if you do this, but if you do something like this, you need to label the tick as a distance of 5. So I don't get confused and accidentally think you're doing 1 unit. So then we draw our 8 petals. I'm going to pause while I do this. This is getting excruciating. There you go. All right. And then there's one more, 3 sine 1 theta. This one I didn't put in parentheses, but it's 1 theta. That means there would be 1 petal, right? It's 3 units long. And in order to find the angle at which that 1 petal goes, that 1 petal is going to be at the angle of 90 degrees divided by 1, which is at 90 degrees. So my one and only petal is going to go straight up towards 90 degrees. It is 3 units long. And if you have 1 petal that goes up 90 degrees, what that actually ends up being is a circle. So we're going to have 1 petal that goes up to 90 degrees. Wow, I missed. We're going to pretend I hit that. There's my 1 petal. And that actually ends up being a circle. And if you are paying attention, and if I haven't caused you to go brain dead by the end of this 20-minute video, you would have recognized that 3 sine theta is that form of a circle that we talked about a long time ago right here. Actually, we did 3 sine theta. So if you don't recognize these as circles, the number times sine or cosine theta, you could always treat it as a one-petaled rose and get the graph just as well. Just a little bit more complicated if you want to think of it as a rose. So there you go, and I'm done.